At the beginning of the 21st century, the Zumwalt-class destroyers were introduced with great expectations, promising to revolutionize naval warfare with unmatched technology and stealth capabilities. They were envisioned as the most advanced surface combatants ever built, designed to carry out multiple mission types ranging from deep-sea combat to coastal bombardment. Unlike their predecessors, which focused primarily on traditional naval roles, the Zumwalt-class was intended to blend stealth, firepower, and cutting-edge electronics into a single platform. This shift represented not just an evolution in shipbuilding, but an entirely new philosophy in naval strategy. The destroyers were designed to be nearly invisible on radar, allowing them to approach enemy shores undetected and strike targets on land with powerful and precise artillery. Zumwalt was developed with stealth in mind, featuring a sharp, angular profile that could mask her massive 16,000-ton displacement and make her appear on radar as no more threatening than a small fishing vessel. The ship incorporated a tumble-home hull design, narrowing as it rises above the waterline and ending in an inverted bow. This structure helped reduce her radar cross-section even further, allowing her to elude detection and reduce her vulnerability in hostile environments. Her mission profile originally included land attack, anti-air, and surface combat capabilities, placing her in a category all her own. Neither a traditional destroyer nor a conventional battleship, but a hybrid meant to support ground forces and dominate a variety of combat environments. The concept for the Zumwalt class emerged in the 1990s under the DD-21 Land Attack Destroyer program. However, due to budgetary constraints and shifting defense priorities, the project was restructured and renamed DDX before being finalized as DDG-1000. It went through numerous phases of development and reconfiguration, eventually becoming the single largest line item in the Navy's budget. Several major American defense contractors contributed to the program, including Raytheon as the systems integrator, Northrop Grumman and General Dynamics Bath Iron Works for mechanical and structural components, and BAE Systems for the advanced artillery systems. Participation from subcontractors spanned nearly every state, reflecting the project's national scale and complexity. Despite the wide collaboration, delays and funding issues prevented significant progress until 2008, when General Dynamics was finally contracted to begin construction on the first ship. USS Zumwalt was named in honor of Admiral Elmo Zumwalt, a reformer who modernized the U.S. Navy during his tenure. The ship was laid down in 2011 and launched in 2013. By early 2014, she began undergoing sea trials to assess her performance in various operating conditions. She officially entered service in late 2016 and was assigned to her home port in San Diego, California. Her immense size, measuring over 600 feet in length and displacing more than 16,000 tons, made her the largest destroyer ever constructed for the Navy and one of the largest in the world. Yet due to her stealth configuration, her radar signature was comparable to that of a much smaller vessel. Her captain, James A. Kirk, remarked that Zumwalt was a marvel of engineering, capable of undertaking the most demanding missions with unmatched versatility and power. From the start, the ship was built with a multi-mission focus. While capable of traditional roles such as anti-air, anti-surface, and anti-submarine warfare, she was also envisioned to provide direct support for ground operations. Her armament included two 155mm advanced guns, each designed to fire long-range projectiles with high precision, and the Mk-57 vertical launching system, which allowed her to launch various types of missiles. The guns had an intended range of over 60 nautical miles and were built to deliver rocket-assisted, GPS-guided shells that could neutralize targets deep inland. In addition, the vessel included a large flight deck and hangar space to accommodate unmanned aerial vehicles and manned helicopters, each armed with torpedoes and anti-tank missiles for reconnaissance and strike missions. A standout feature of Zumwalt was her integrated power system, which made her an all-electric ship. Quiet and efficient, this system generated all the energy required to operate the vessel's systems and propulsion. Her power output reached up to 78 megawatts, equivalent to the power produced by some nuclear-powered aircraft carriers. This allowed Zumwalt not only to meet her own energy demands, but theoretically to power a small city. The ship used Rolls-Royce MT-30 gas turbines and RR 4500 generators, enabling her to reach speeds of up to 30 knots. Her electric motors and cooled exhaust system further reduced her visibility to enemy sensors, making her extremely difficult to detect through infrared and acoustic tracking. Internally, the operations center was designed to be highly adaptable. It included portable computing devices accessible by any crew member, and over 15,000 square feet were allocated to Linux servers that ran the total ship computing environment. This digital network allowed crew members to access critical systems from multiple locations on board, enhancing operational flexibility. The ship was also equipped with sophisticated sonar arrays, including a dual-band sonar suite mounted in the hull, useful for tracking submarines and underwater threats. Despite these technical breakthroughs, Zumwalt's story is marked by significant challenges and unfulfilled promises. Construction began before many of the ship's technologies had reached full maturity, and by the time she was delivered, essential combat systems were still not operational. A 2018 report by the Government Accountability Office revealed that fewer than half of the ship's key technologies were functioning as intended. At a cost of $4.4 billion per ship, twice that of the already expensive Arleigh Burke-class, the Zumwalt became the most costly destroyer in Navy history. The entire research and development effort for the three ships ultimately cost over $22 billion. The original plan to build 32 ships was quickly abandoned as production costs soared, and only 3 were completed. While the advanced technology allowed for reduced crew sizes, this too became a point of concern. Zumwalt, which is significantly larger than previous destroyers, is operated by just 158 personnel, along with a 28-person aviation team. Though the Navy initially claimed that fewer than 100 crew members would be required, the final complement was still half the number needed to run Arleigh Burke-class ships. Critics have argued that a smaller crew limits the ship's ability to respond to damage or combat situations where redundancy is vital for survival. Technical malfunctions further complicated the destroyer's service history. Zumwalt suffered a major breakdown while passing through the Panama Canal in 2016, and her sister ship, Michael Mansour, failed her sea trials the following year. Cost-cutting decisions led to reductions in air search capabilities, saving about $80 million per ship but severely limiting combat effectiveness. By 2018, military analysts concluded that the Zumwalt-class had largely failed to fulfill its role as a multi-purpose warship. The mismatch between design intent and operational reality raised serious concerns about the viability of the entire program. One of the most critical setbacks involved the advanced gun systems. The long-range projectiles they were built to fire were eventually deemed too expensive, costing nearly $800,000 per round. This was comparable to the price of cruise missiles, which are more accurate and have longer ranges. The projectiles were canceled, leaving Zumwalt with 2 powerful guns and no ammunition. Without munitions, she could not carry out her primary mission of providing fire support during land operations. As a result, the Navy was forced to rethink the ship's role. With the cancellation of the land attack rounds in 2016 and no replacement in sight, the Navy repurposed the class for surface warfare. Several roles were explored, including using the ships as dedicated ship hunters, but this would have required stripping away other capabilities, such as anti-aircraft and anti-submarine systems. There were discussions about arming the ships with nuclear cruise missiles, but as rival militaries grew stronger and more sophisticated, such specialized roles seemed impractical. The Navy eventually decided in 2021 that Zumwalt-class ships would serve as platforms for testing hypersonic missile technology. In early 2022, plans were finalized to outfit the ships with hypersonic weapons, with the project expected to conclude by 2025. Lockheed Martin was tasked with the integration process, working alongside experts in military and aerospace electronics. The inclusion of hypersonic technology may finally give the ships a defined and valuable purpose. Yet the long and troubled development path of the Zumwalt-class destroyers has left many questioning whether the ships were simply too advanced for their time. Their immense technological promise was never fully realized, and despite the efforts to find them a role, they remain emblematic of a high-risk, high-cost military project caught between innovation and reality.